Class, so now we go to the first method of solving linear algebraic equation, which is graphical method. This method is suitable to be applied to a linear algebraic system of two equations only. However, you also can apply this method to three equations, but it become complicated because you need to know the plotting of three-dimensional system. This equation will be plotted on Cartesian coordinate. What does it mean Cartesian coordinate? Means that the rectangular coordinate that we have here, x axis and also y axis. Each equation will represent a straight line. Why here straight line? Because now we learn about linear equation. Linear equation will give you just straight line when you plot on the graph. And then the intersection point provides the solution to the corresponding unknown. Means that here when we have, for example, this one is our first equation which gives us this straight line. And then this is our second equation. The intersection point here is the solution of our problem. For example, here we have two equations. There is two systems here, a11x1 plus a12x2 equal to b1, a21x1 plus a22x2 equal to b2. We can solve this one by make, for example, here x2 as subject. So in this case, we can write this equation. For the first one, we have x2 equal to b1 minus a11 x1 divided by a12. When we rearrange this one, we'll got here negative a11 divided by a12 plus this one times x1, so plus b1 divided by a12. This equation we can write in terms of actually general. We have y equal to mx plus c. So y in this case is x2. And this m is referred to, this one is actually m, which is m here is slope. So we have in this equation, this one as our slope, and this one is it is intersection point of y-axis, that is the intercept of y-axis that is given by this c given by b1 divided by a12. In this case, when we plot, we can draw a graph based on a linear equation of y equal to mx plus c. And when we write this second equation in terms of x2 as subject, we'll got this kind of equation, which is here this one is slope and c is given by b2 divided by a22. So class, let's say we have this example. Use the graphical method to solve the following equation. The first step here, we need to solve for both equations for x2. Here, I can write x2 as subject. That is, for the first one, I have 2x2 equal to 7 minus x1, which is here, x2 will be equal to 7 minus x1 divided by 2. So we'll have here negative x1 divided by 2 plus 7 over 2. In this case, our slope that is m will be equal to negative 1 over 2, which is the coefficient of x1, and c is given by 7 over 2. And then for the second equation here, when we convert as x2 as subject, we will have here x2 equal to, that is this 3x2 equal to 7 plus 2x1, which is equal to here 7 plus 2x1 divided by 3, that is equal to 2 over 3x1 plus 7 over 3. And in this case, class, we can see this is our m and this is our c. So we got all these equations, and from here you can draw a graph for this linear equation. Means that when you plot the two equations on the Cartesian coordinate, you will have here the graph of this one x2, x1. So now we have, based on previous calculation, we have the first slope is negative 1 over 2, and the intercept point at y-axis or at x2 equal to 7 over 2. Means here, for example, we have this 1, 2, 3, and then 7 over 2, it is around 3 point something, let's say here. And then we have slope negative 1 over 2, so that roughly our graph will be like this. And then for the second one, we have here 7 over 3, which is this one is 2 point something, let's say it is somewhere here, you can actually plot using graphical paper, and then the slope is positive, so the graph will be like this. Okay, the graph will be like this. Means that here we can see the intersection point. So this intersection point is the solution of our equation. When you plot using graph paper here, you will see this one is the value of x1 will be equal to 1, and the value of x2 here actually it is equal to 3. Means that the solution for this equation x1 equal to 1 and x2 equal to 3. This is how can we solve our linear system, which is two equation, by using graphical method. So class, we can summarize graphical method actually according to this. Given the two lines L1 and L2, and one and only one of the following may occur, means if we have here L1 and L2 intersect exactly at one point, then we can say that our solution is unit. What does it mean by unit solution? Means that if you refer back to the previous example, we have just one point here, so we only have one x1 and one x2. This solution means that unique. If L1 and L2 are parallel and coincident, so there is an infinitely many solution. Here means that if this, for example, is L1, and then we have also L2 on the same line as L1. Okay, means that it is intersect at all points here. So there is infinitely many solution. If L1 and L2 are parallel and distinct, so there is no solution. We can see next here the example. So this example 2, determine the nature of the solution for the following system of linear equation. Your first step here, you need to plot this graph. Okay, plotting this graph, you will got this kind of, this is, for example, this one is L1, this one is L2. So here there is no intersection point, and it is actually L1 and L2 are parallel, means that there is no solution. And then class, if you refer next, okay, to this example, determine the nature of the solution for the following system of linear equation. When you plot here, you have got actually L1 and L2 are almost parallel, but at this point, it is hard for you to identify the solution, means that we said that this system is ill conditioned. And then if you refer to this one, determine the nature of the following system of linear equation. Of course, the first step you need to plot. When you plot here, you can see L1 actually equal to L2. It is coincident and parallel. So many solution, because actually this line is intersect at all points. And then class, for the graphical method, it is limited to small number of equations, whereas in this chapter, you will learn only for two systems. How we can solve if we have, for example, 3 by 3 system, 4 by 4 system, and more complicated system. In fact, we have many methods that we learn later, but for this, for the starting point, you need to know about the Cramer's rule. Cramer's rule is a method that states for each unknown in a system of linear equation, it can be expressed as a fraction of two determinants. Okay, so the each unknown can be expressed as a fraction of two determinants. The denominator D is computed by finding the determinant of A matrix. The numerator Dn is obtained by replacing the column of the coefficient of the unknown by the vector B. So in this case, class, we can solve. For example, we have here, for example, we want to compute xn, so the formula is given by dn as the numerator divided by d. What is dn? Dn is dn is the determinant that we obtain by replacing the column of the coefficient of the unknown by vector b. So we will see later the example to apply this formula. Okay, and this D is determinant of a matrix. How can we apply this formula? But before that class, you need to know how to compute determinant for small dimension of the matrices. The complexity of using Cramer's rule is you need to find the determinant of matrix. So if you have system one by one, the determinant of one by one, we just call it scalar. The determinant of the scalar is equal to that value of the scalar, which is, for example, here we have 2. If we compute the determinant of 2, it is equal to 2. If we have 2 by 2 system, so determinant is given by A11, A22, means that this one times this one minus A12 times A21. For example, here I have 1, 2, 3, 4. So I want to compute the determinant of this matrix, means that 1, A11 here, 1 times 4 minus 2 times 3. So we've got here 4 minus 6, which is equal to negative 2. And then if we have 3 by 3 system, the calculation become more complicated as we need to find the determinant here equal to A11, this one, okay. We'll close here and then here the intersection happen here. So we take it as A11. We compute next the determinant of the rest. Okay, so minus next, we close the second part with the second column with the first row. We have A12, and then we take determinant of A21, A31, A23, A33. And then we plus the next one, we close the last row and the last column and the first row, and then you will have here A13 here, so plus A13, and then you need to find determinant of all these A21, A22, A31, A32, and then you can apply for 2 by 2 here to find this determinant. So when you expand it, you can get this formula for 3 by 3 matrices. And then class, how can we find uh, the unknown by using Cramer's rule? Remember, Cramer's rule is equal to xn equal to dn over d. If you have a system of x, which is we need to find the unknown of x1, x2, x3, means that this n is referred to either 1, 2, or 3 because this n will represent the unknown of the x. And here, when we have here this n equal to 1, so x1 equal to d1 divided by d. And remember, the meaning of this d1 is means that you need to replace the first column with vector b. So now you need to compute the d is referred to determinant of the matrix where the first column here replaced by vector b, and you divide with determinant of this one is determinant of a matrix. And then class, when we want to compute x2, okay, so x2 means that we have d2 divided by d. So in this case, when here d2 means that second column you need to replace with vector b, which is then divided by determinant of a matrix. And then if we have here for this x3, so here is 3 means that the third column here we need to replace by vector b. So we compute its determinant and we divide by determinant of a matrix. We go class to this example. Given a system of linear equation, the first question asks you to transform the above system into a matrix form of Ax equal to B. So now for this case, we can write into of Ax equal to B by, we have here, this is A, this one is x. So x, we have 3 unknown here. So we have x1, x2, x3 equal to, and b is, which is here, this is your b1, b2, and b3. We have negative 8, 13, negative 4. But for this a, it is a coefficient of each x. So the first equation we have x1, so we get 1, 3, negative 1, 2, negative 1, 3, 3, 2, negative 1. Means that you will have this kind of system Ax equal to B. And next question asks you to compute x1, x2, and x3 by using Cramer's rule. in this case, what we need to do is, you need to find first determinant of A matrix. And this is your A matrix. And to compute the determinant, okay, we have here 1, 3, -1, 2, -1, 3, 3, 2, -1. We can close this one. So we got 1 times the rest determinant of the rest value that not close here, which is -1, 3, 2, -1, minus. Then we close a second column, the first row. This one not yet closed. And then we have here minus intersection point here. The intersect here is 3, 3. And then you have the remaining value here, 2, 3, 3, -1. And then plus, we close now the first row, third column, -1 times determinant of 2, -1, 3, 2. When you solve this one class, you got 21. And then you need to find determinant for each D1, D2, and D3 by replacing the first, second, and third column in A with B. Means that to compute D1, we see here, instead of we have this 1, 2, 3, now we have B for the first column, which is -8, 13, -4. And then we do the same thing as this one, but now the values is differ. So you when you solve, you get here 21. And then for D2, okay, the second column here we change to, this one originally is from A matrix. But when we want to compute D2, means that the second column you need to change here with B vector. And then you compute determinant by using the same way, you will got the answer -42. And then for D3 here, okay, the third column we replace by vector B. Means that originally it is from A matrix, and then you solve it, you find the determinant here, you got 63. And we know the formula xn equal to dn over d. So to compute x1 equal to d1 over d, and d1 is given from previous that we have computed, which is 21 over 21. So we got 1. And x2 will be equal to d2 divided by d. So -42 here divided by D, we'll got -2, and x3 equal to 63, which is here, this one is D3 divided by D, we'll got equal to 3. And then finally, we will have here, therefore, all x here, x1, 1, x2, -2, and x3 equal to 3. This is how class you can solve by using Cramer's rule. As a conclusion here, graphical method is applicable for system of two equation only. Cramer's rule is suitable for a system of 3 by 3, but when you have a high dimension system, you need to compute determinant of high dimension matrix that will make it is complicated to be solved. So how to overcome this complexity, we'll go next to the more interesting method that we learn in the next video, which is knife gauze elimination method.